Hey guys, let's talk about rationalizing the denominator. When you are working with trigonometric ratios, you're inevitably going to be dealing with fractions, and a lot of times those fractions will contain radicals. And in mathematics, when the denominator of your fraction contains a radical, in other words, a square root sign, um, we don't want to leave it in that form. That is not considered proper. And so to take care of that, let's review what we would do. So the main idea is we're going to take our fraction and we're going to be multiplying it by another fraction that is equivalent to 1. The reason being, if we multiply by 1, we're not going to be changing the value of our fraction. We might just change what it looks like because we're going to select this fraction that's equivalent to 1 in a special way. The numerator and the denominator will be the same, but in doing so, this multiplication will cause the radical in the denominator to go away. So at least that's our goal. Let's take a look at some examples. So the first example that I have is 7 divided by the square root of 2. So this is not unlike something you might run across in trigonometry. The problem being, again, that our denominator contains a radical sign, which is not considered proper. So what we're going to do is we're going to multiply this fraction by 1. We're going to choose that 1 to be very special. And so what I'm going to do is I'm going to select my fraction that's equivalent to 1 to be the square root of 2 divided by the square root of 2. Now, clearly, this fraction in red is equal to 1. So when I multiply it by my original fraction, I'm not going to be changing the value. However, by multiplying by the square root of 2 over the square root of 2, I end up with 7 square roots of 2 over the square root of 4. And since I have created a perfect square in my denominator, a number that I can take the square root of, the square root of 4 is just 2. So now my denominator is a nice rational number. There is no radical in the denominator. And what often happens is you will end up with a radical in the numerator instead, and that's okay. So a couple of things to note. Remember that when you have a number that is not under a radical sign and you're multiplying it by a number that is under a radical sign, really all you do, in this case, you would just say 7 square roots of 2. You can't really, those numbers don't really get to do math together. We just write them together. However, in the denominator, when we multiplied the square root of 2 times the square root of 2, we could let those numbers do math together since they are both under the radical sign, okay? So our goal is to create a perfect square number in the denominator so that we can take the square root of it and eliminate the need for a radical sign. And that's what's known as rationalizing the denominator. Let's look at a second example. So here I have 7 divided by the square root of 12. So I want to turn 12 into a square number. And your first thought might be, well, in keeping with example 1, maybe I'll just multiply by the square root of 12 over the square root of 12. And guess what? You certainly can. That would actually work out okay for you. But you would need to simplify this radical in the end, and I'm trying to avoid that. So what I want to try to do really is try to multiply by something, the smallest thing that I possibly can to create a square number in my denominator. So let's think about what the square numbers are. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. I finally hit a number I think I can work with because 12 divides evenly into 36. So if I can make this number become 36, then I could certainly take the square root of it because 36 is a perfect square. So what I'm going to do is I'm going to take this fraction and multiply it by the square root of 3 over the square root of 3. And the reason I've selected that is because in the denominator now I will have the square root of 36. And of course, the square root of 36 is just 6. So I don't worry too much about what the numerator is looking like, it turns out the numerator is going to have a radical sign, but the denominator is not. And that's the entire point of rationalizing the denominator. Let's do another. So let's look at 7 divided by 3 square roots of 5. So sometimes your radical sign has a number in front that is multiplied. And I wanted to do an example like this to show you that when you're trying to rationalize the denominator, you're not really too concerned about the 3, but you're really focused on that square root of 5. So you want the square root of 5 to be the square root of some perfect square. And 5 being a prime number, there's not much else to think about. We're just going to multiply this fraction by the square root of 5 over the square root of 5. And so now what happens is, of course, the 7 and the square root of 5 don't really get to do math together. And guess what? The 3 doesn't get to do math with the square roots of 5. But the square roots of 5 multiply together, making the square root of 25, which is, of course, just 5. And so this is the part that sometimes students don't quite know what to do with. Some students leave it like 35, but this means 3 times 5. So go ahead and multiply 3 times 5, and you end up with this final solution that has the rational denominator. And let's take a look at one last example. Now, I wanted to do an example like this because notice this time I am not working with a square root, but rather a cube root. Now, the cube numbers, remember that means numbers that are formed by multiplying a number 3 times, like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So those are the cube numbers. 9 is a perfect square, but it is not a perfect cube. The number that I mentioned that I think we can work with is 27, which is 3 times 3 times 3. So if I multiply top and bottom by the cube root of 3, then that's going to give me a nice cube number. So in the top, once again, the 7 and the cube root of 3 just hang out side by side. But in the denominator, I end up with the cube root of 27, and the cube root of 27 is just 3. So rationalizing the denominator, a lot of times with trigonometry, you'll be dealing with square roots, but it works for cube roots and fourth roots and all the other types of roots that you might see. Notice that all of our final answers have rational denominators. In other words, there are no radical signs in the denominators. So congratulations, you have learned to rationalize the denominator.